Hey everybody, we're back. So we're gonna move on a little bit, and I'm gonna try to keep this simple because it is fairly simple. But obviously, when you start dealing with a lot of wires, things look confusing, but it's really not that bad. So the reason I took this approach is because there seems to be a lot of unknowns when you're troubleshooting what's going on. Even with a multimeter, you can read resistances and things of that nature, but then when you put a power supply to it, and it doesn't work, you're left guessing, is it the gauge, is it the sending unit, is it the wire? And I think, for at least for me, peace of mind would be if I could see the gauges operate properly before I install them, then I would have more confidence in what I bought. That seems to be some of the concerns out there, that the gauges are cheap and when you get them in, they're duds. But I think that a lot of that is probably grounds missing, things of that nature, and possibly even burning the gauges up when you go to install them. So my thought is to take a step-by-step approach. First thing was to prove that the gauges work, install them, and hopefully things have better results. So that was my intent. Again, another one of the unknowns are the voltage that you're supplying. I did some testing on some old ones, some old gauges, and it seemed like I had 12 volts everywhere, which is not what the gauges operate on. And again, that's kind of a point of failure, that an unknown that I wanted to eliminate in a step-by-step process. So in order to do that, what I've done is created kind of a little test board, if you will, with just a couple of pretty basic components. The first one over here at the top left corner that you see is just a terminal strip. All it's doing is it's a terminal strip for my ground. You see this black wire, it actually runs over to a ground on my Jeep. The other grounds that are coming off this terminal strip we'll kind of walk through here in a second. The other component that I have added here is just simply a DC to DC converter. So this is a 25 watt DC converter. It takes either a 12 volt or 24 volt input and provides a 5 volt output at 5 amps max. So that's 5 times 5, that's how you get to the watts, or the 25 watts. So 5 volts times 5 amps is a 25 watt converter. That's which is the reason I'm explaining that, is because it's probably excessive. If there's 5 amps going through these gauges, it's probably going to burn the gauges up. So I could have gone with a much lower one, now that I stop and think about it. In fact, another approach would be to actually put on the outlet side of this an inline resistor, or fuse, if you will, probably like a 0.3 milliamp fuse. And hopefully that would protect the gauges even more. So that might be something I'll consider as I actually do the install. But again, so we have here coming in, we have a 12 volt power supply that's running over to the Jeep. That's where that red wire is going. And then on the inlet side, we have a ground as well, and that's wired back over to the terminal strip. So that's what's coming into this voltage regulator. What's coming out, we have 5 volts coming out. That's actually right over here, and it is just dangling. That's this guy right here. So you'll see later on, this actually is going to be our power supply to the fuel gauge, and we'll also use it on the temperature gauge when we kind of mock those up. We also have dangling here just a ground wire that's running back again to ground. That's going to be our grounding wire to our gauges as we mock those up. And then we have here a green wire. That is going to be our sending unit wire that we're going to hook to the gauge as we mock those up. So going back to our schematics and everything, what we've kind of put on this board is essentially our incoming power coming to the gauges. But again, in this scenario, we've actually installed an external regulator that we're going to provide 5 volts to the gauges to make them work. So we have our grounds. We have that with the black wires that we just walked through. We have the supply. We'll have the gauge, So the thing that we're missing are basically the sending units, whether it's the fuel or the temperature, and we'll probably start with the temperature first. We don't have a sending unit on this board yet. So in order to demonstrate a sending unit that we know works and we know the exact resistance, we've added this guy, which looks kind of complicated. And I've used a clear box so that you guys can see what's going on here. This is a potentiometer. So potentiometers, it sounds confusing, big word. I can hardly spell it most of the time, but it's really not complicated. So what a potentiometer does, it's kind of like a speed controller. It's exactly what it is. So you can use this to slow a motor down, dim lights, things of that nature. That's if you utilize it to change basically the output voltage from the potentiometer. But that's not what we're going to use it for. We're actually going to use it to control the resistance. So let's kind of look at a schematic of a potentiometer. And they're all basically the same. So a potentiometer has 3 points of contact. And what this is, again, is it's an ability to change resistance. So you have a resistor that runs around a circle. And the 2 points of contact that we're going to look at is basically the change in resistance as this thing moves further and further across this wire. So when you look at the bottom of the potentiometer, it's just a wire, and as you rotate the dial, the point of contact moves, basically putting more length, more resistance between 2 points, and that's how it changes the resistance. So the reason we're doing this is because when you look things up online, you'll find out that these gauges are basically just reading resistance. That's all they're doing. So they have a range, and again, you can look these up. So for the fuel gauge, when the sending unit is providing a 73 ohm resistance, the gauge is going to read that as empty. And when we're at 23 ohms, it's going to read that as half a tank. 10 ohms is going to be full. So what I've done is I've installed this potentiometer, and I'm using those 2 points. So a couple of wires that we have ran here is we basically have the ground wire coming off this first point running over to our ground. And I've got, you can run it over to the terminal block. I've got it landed here on the voltage regulator. Same thing. But that is our ground wire because, again, in our diagram, our sending units, whether it's the fuel tank or the fuel level or the temperature sensor, they have a ground to them. And I'll be honest, I just added that in a few minutes ago. It wasn't in the earlier videos. So we have to have our ground, and we have to have the wire going back to our gauge as the sending unit wire. So that's what we have here. We have just 2 wires. Again, we have the black wire, which is running over to ground. We have our green wire, which is going to be our sending unit wire. And this potentiometer is going to be our sending unit, temperature and fuel, depending on which one we're testing at the time. So what I've done is I went ahead and hooked this up. Before putting power to it, I went ahead and I read the resistance from point to point, and I dialed it in to be 73 ohms. So 73 ohms was an empty tank. I dialed it in to be 73 ohms. I went ahead and wrote it on the board. I did the same thing for half a tank, which is at 23 ohms, and I did the same thing for a full tank, which is at 10 ohms. So I did the same thing again for the temperature sensor. So we know at cold it's 73 ohms, hot it's 9, and there's a couple of points in between. So again, 73 ohms is cold, and then 9 ohms is hot, so basically 10, but we went ahead and wrote it there. So that's what the point of the potentiometer is. Actually, at this point, it's more a rheostat than a potentiometer because we're just using it to change the resistance. So we'll be able to hook the gauge up, dial this to any point, and the gauge should respond accordingly. And we know for certain that we have a fully functional gauge before we crawl up underneath that dash, get a kink in our neck, strain our backs, cuss, and everything else. So we'll do that here in just a second. All right, thanks.